Why don't fish freeze in the Antarctica? As the Antarctic is known, it is an inhospitable place for normal life due to very low temperatures, with strong snowy winds blowing all the time. Perhaps this makes us wonder about the ability of fish to adapt and live in these compelling conditions, especially since they are sensitive to environmental changes and can die for the simplest reasons. Cold-blooded fish, a phrase that we often hear but we don't know exactly what it means. A cold-blooded organism is an animal whose body temperature depends on the environment around it. It appears in fish, reptiles, and other amphibians. On the other hand, warm-blooded animals can maintain their body temperature. Most warm-blooded animals have few problems adjusting to a range of different temperatures. This is mostly seen in mammals and birds. Some fish have adapted to the warm-blooded diet, such as Pacific bluefin tuna, which exhibit heat exchange from arteries and veins. The aba, a fish found in Hawaii, is actually warm-blooded. However, this is not the case with Antarctic-dwelling fish, where they are cold-blooded, but they have developed an interesting adaptation. It is important that blood flow throughout the body of the organism continues to survive. Blood is a carrier of oxygen and nutrients to different parts of the body. So what will happen to normal blood in Antarctic organisms? As a general rule, a large part of our blood is water, 90% of it, meaning that our blood will freeze in the South Pole. Due to the high salt content in the ocean, the temperature of the frozen water drops to -1.9 degrees centigrade. Sub-zero temperature leads to the formation of ice crystals in the blood. When these crystals form, they damage all of our cells. Cold-blooded fish, in particular, find other ways to combat sharp temperature drops, as they don't rely solely on their body heat to survive. When we say antifreeze, we mean certain compounds that are added to water to reduce its freezing point. The way typical antifreeze works is to prevent the formation of ice crystals. Arctic fish have compounds called antifreeze proteins in the fish's body, and these compounds are produced like any other protein in the body. Ice is formed when water is compressed into a certain crystal lattice. What this means is that water condenses as the molecules get closer together, and as the intermolecular space decreases, the water molecules attract each other more strongly, resulting in the formation of a crystal lattice. Antifreeze proteins in the fish's blood enter these crystal lines and prevent them from fusing together. If they prevent crystals from fusing together, they can't form ice in the blood. At the very least, they can't form ice crystals large enough to cause any damage to their bodies. Antarctic fish were not the only organisms to have developed this property to adapt to malleability. Antifreeze proteins are found in many other organisms, including ice diatoms and some bacteria, as well as snow mold fungi and even some beetles. The interesting thing is that these adaptations evolved in different ways, but ended up achieving the same result. The bottom line: antifreeze proteins protect the blood of Antarctic fish from the formation of ice crystals and coalescence between them, which ultimately protects them from dying frozen by low temperatures. Why don't fish freeze in the Antarctica? Please support us by pressing the like button and follow us to receive everything new. Wait for the next video.